Mikhail Rusakovich, Scalable reference and libraries of threats.
Так. Меня зовут Русакович Михаил, я инженер по безопасности приложений компании EPAM. В докладе я хотел бы затронуть популярный...
I would like to speak about the popular topic of the development cycle of secure software, and in particular, I would like to discuss the design stage and modeling the threats. Many people underestimate this stage because they believe it's superfluous. You can just take a checklist and give it to the developers, and that's your security. That's how you implement your security. In fact, it's not exactly like that. So modeling these threats, simulation of threats, is a link between the requirements that we determined in our first phase, where we will determine the risks for the application and the data and the confidentiality
этих данных, потенциальных атакующих для приложения.
And so the vector of attack. So modeling of threats. It connects the stage of requirements with implementation. So threat modeling. So all of you, so we started to model threats starting from this primitive step using free program that like threat modeling tool that could be downloaded from Microsoft site for free. And everything that you do is you determine the diagram, the architecture of your application, then you determine how data come in and and then you get this eventually. This huge lots of threads you get. And all threads, so they require filtration. They require prioritization to be prioritized. So then the clear model of prioritization is very important because threats lots, and that's why we need to prioritize. And most threats are not applicable. So then access to database, weak access to database, some are not relevant at all, and that's why can be disregarded. So when we deployed it, and we started out with this, and we came to the conclusion that this process is very time-consuming because we need to see each threat, classify each threat, then study each threat, and in accordance with this model, verification should be done. And then eventually to either accept this threat or reject this threat. The most important problem of this approach is that so then the study of those threats takes a lot of time, and this is why using this model of security advisor, security champion, whether security specialist who is an expert, and SDLC and security champion. So who the guy who is has been seconded by the team, and he's responsible for the project, for specific project. And on the basis of this interaction, so the deployment of SDLC is built. To what extent this interaction will be efficient? To the same extent, the modeling of threats will be efficient. So one comes with the other, and much depends on what questions will set to security champion. So what recommendations we need to give to the security champion, and what is the framework, and then there's the proper questions put to the security champion depend on the clarity of modeling and precision of modeling. Then the regional process looks like this. So all the threats that we get, we classify them based on our risks, based on our vector of attack, based on our profiles of attackers. It could be endogenous, exogenous attackers, and based on the data involved and the level of confidentiality, clearance, availability. And then we all these identified threats we assign to the project team, and then they do the investigation. So whether this threat is applicable to this specific for them, is it relevant for them, and if they take it as a threat, then they do the implementation. So the weaknesses of the model are obvious. This non-transparent process for the security advisor, because we don't know whether the team did it right, did the mitigation right or wrong, and whether they did the investigation correctly, and there is no feedback with the security commander. Then another thing, the security command is not, they're not working very hard. So we did it once, this cycle, several cycles, and every time we realized that the modeling, threat modeling, takes too much time, and we started to think, how can you improve it? And we decided that why don't we map all threats that we're getting and our security practices concerning configuration, and put one set against the other, infrastructure solutions, and put it into a special model. So thus we define the already finished ready model that we give to the team, to the developer, and all they need is to implement the ready-made security practices, finish and don't do any investigation. No need to do that, and not to spend time for the investigation of threats, and not to look how to mitigate this specific threat on a specific platform and this specific solution, etc. So we followed on this process of storing, mapping our security practices and threats, of mapping in reference model. We turned it into reference model, and we got this process. And so when we give the team our model, so safe model, where all the mitigations are observed and all the threats are identified and mitigated, and all we have to do is to do the verification of their architecture and their code, and to implement this. So this is a model example where we implemented many security patterns, DMZ. If you have confidential data and you need to protect it, and you need to identify data storage and put it in a different closed network. So then we started to think about the accuracy of our threat modeling. And actually we always dealt with general threats, not technology-specific threats. So we have a threat, for example, a tampering information disclosure for a specific data flow. And we understand that this data flow can, so there can be different protocols, there could be different variety of data move around. And so the problem had to do the elevation of privilege, elevation of privilege, so could be exploited differently in different servers, on different servers, on different platforms, and Jinx, for example, and it could be a module which you forgot to turn off, and the attacker attacked, and do the remote code execution. And in Apache, it could be a different module, so then that could actually address the same issue and had the same problem, etc. But these threats, they're technology specific.
For a specific application or platform, database, and so on. So at the next stage, we tried to identify such threats with every technology of our models. And gradually, we accumulated these data, and we found so-called a library of threats, where we keep all the information about all the threats. It may be both general nature threats or those that use this specific technology, and again, DBs and processes and some environment. And then we saw that when we kept accumulating threats, we saw an interesting thing. Very often they may repeat themselves. They may reappear. If we take a DB, then information disclosure from the file system, it does not make sense to list in every model for each DB. We can actually group them into an abstract level and determine some kind of model of inheriting to simplify the management of all threats. And we continued refactoring our model, and we got approximately this model when at the top level we have general threats, then SQL DBs, and then we can continue specific implementations of Mongo, Postgres, and MySQL, SQL Server. So finally, we need to take high-level threats, then add the threats that are specific of no SQL-specific data storage threats, and then MongoDB specifics. For instance, MongoDB injection, where you allow scripting for your DB. So we made it for the processes. For Nginx, then there will be a similar situation that we determine common threads for front-end server and the thread specific for Nginx. And then we noticed one more thing, composition of threads. If, for instance, your process is at some Docker container or within a server, within some environment, it's clear that the threads for those such processes are cumulative threads within which the process lies. In this case, the threads related to the network, server, and threads linked to specific process. If, for instance, you have problems somewhere with a port, server port, then it makes sense for the process to describe complete model, comprehensive model. And the last stage that we added to the library is how specific threads should be verified. If we take this simplest CSRF threat, we can verify through security code review and see there is no token and synchronization. I will look into the configuration of application and find that CSRF protection is not included. And it's rather a question of convenience of verification of specific threats. It's clear that there are many ways to do it. But now we work on convenience to identify which is more convenient. For instance, it's good to set a rule for static analysis, and it will find all spots. For instance, if you have 100, it's clear that manual security testing is difficult to do, considering the time it may take. For penetration testing. And the last thing I wanted to mention is that we certainly can build the ideal model of threats, cover all risks, mitigate virtually everything. But most important, don't forget about our model. If we make a threat model and then left it in the new release, we may add some functionality, some button that will be accessible to unauthorized users that can drop all our tables, and all our threat model will go down the drain. So the compulsory process is building a model of threats for the new functionality that you introduce. You have to upgrade it and continue the process within the building the threat model. So the library that we have built can be supported. Both security experts, they may put all the security practices in, and simple developers who can give recommendation on technologies, Java, C, .NET, and you may also store their infrastructural threats. And in such a way, we shall get the general library, which may be reused by other projects. If, for instance, you use any DB, you can just go to this library and look up what the threats and at the design stage account for them, and ensure security at the design stage, and he will not need to do additional verification and so on. So in such a way, you can save much time. I'm done. Thank you. Thank you. Yeah, hello. Thank you for the wonderful presentation. I would like to ask you in more to describe more in more detail the library processes. Do you mean actualization from the point of view of new features? No, I mean the relevance of the threads and adding new threads and revision. Yes. This library has to be supported all the time, and there are many tools to support it, and Risks and Threat Modeler, and they provide interface which, if you create a model there and you get some new threat, you will add it, and automatically it will be sent to all the project teams, and they will know that it needs to be mitigated, and all models will upgrade. Correct me if I'm wrong, the threat is like a vulnerability. So a threat is potential vulnerability, which we can get. So if we get a vulnerability, an attack, it's dangerous.